Hello and welcome back to Joshi Repair. In front of us we've got an ASUS Maximus Extreme. This is a Z790 board using the ROG A1700 socket, coming for a socket replacement. As you can see, bring that a little bit closer to you. The socket does not look too good at all. Yeah, so we assume that the person or the customer was trying to install the CPU cooler, as you can see from these mounting screws. Something might have dropped into the socket, for example a screwdriver, maybe some threads from some clothing had caught onto the socket, damaged a handful of pins. They weren't too happy, and then it ended up damaging the rest with some tweezers or even the screwdriver, whatever it might be. There's also a bit of a mess around the electrolytic capacitors with some thermal paste. So no problem, there's a little bit of a mess here, but not too much. So we wanted to make a guide type video, kind of outlining how we do the socket replacement, avoiding common issues that a lot of people have asked us about. For example, board warpage, having this part kind of bend upwards and this kind of go straight, so you got a bit of a banana board. Addressing things like avoiding damaging or even knocking around these SMD caps, avoiding damage to these electrolytic caps, damage meaning inflating them, having them explode. Many people have come to us with that, and yes, it is a beginner's mistake. It can happen when your profile is not so great, especially when your top hot air or your top infrared heat is too much. And yeah, anything else we need to address? There might be a handful of other things that we will outline in the video, but for the most part, yeah, we wanted to show it to you on this board. More expensive than most and thicker than most as well, so with that the profile will be different. That is one thing, by the way, we won't be outlining our BGA profile. We will be outlining things that you should be taking into account, but the BGA profile is something you guys need to be doing yourselves. It's something that you need to actually practice with, do a lot of trial and error, trial and testing, take an Excel document and kind of play around with these kinds of things, because with VGA profiles, and you'll hear this a lot, not one size fits all, not at all. And you'll hear it in videos and anyone that gives you advice, because the thing is, it depends on your machine, it depends on the board, it depends on your atmosphere and the temperature of the room, it depends on if there's any wind blowing around, it depends on, coming back to the machine, it depends on the hot air, if it's using bottom hot air or IR at the top, or all these kinds of things that affect it. So just to give you an example, we used to own a IR 12,000 from ACHI, so ACHI, that was the company that made the machine, but it took a lot of work to actually tinker it and to tailor it to our work. And not only that, we had to tailor it for every single board. So it was a big headache in terms of the way it worked and the inconsistency, and the actual preheating plates itself wasn't actually designed like the machine we have now. So the machine we have now, it's actually one big plate, one big heating area, or two separate areas that can be controlled independently. It's a big rectangle. I'll put a photo of it now. It's called the IK650 Pro from ThermoPro themselves in Russia. Can't fault it. A few things we would change, but for the most part, fantastic. So compared to that, it had a handful of different rectangular preheating plates. I'll show you an image again. Was not good. Inconsistent, a lot of cold spots. Some heat spots were actually hotter than others. Even those plates themselves, at one point of the plate would be 300 degrees, another would be 250, another would be 210. It's just not reliable, especially for a board like this. You need heat to be consistent across the board. Warpage primarily happens because of uneven heating. If you've got this part of the board, at 200 degrees and this part is at 70, that's not going to be a good look for you. Trust me. So we'll walk into it. We'll hopefully address each thing one by one. Avoiding these caps. Using methods such as having this kind of put on top of the socket, have your profile, melt the socket and then pull it off with the suction tool. We prefer to use the tweezers, have more control, avoids the issue of lifting up the socket and then it kind of jiggling a little bit, because sometimes what can happen is you lift up the socket and the weight can kind of move. Even if you've picked up from the middle, very unlikely. It happens maybe 1 in 50 times, but we prefer happening 0 in 50 times. So that's one of the things. I'm just briefly outlining each one of the issues. Second one is the caps. You have to be very careful, either when lifting it with the suction tool or with the tweezers. Thirdly, you've got the electrolytic caps. That's actually going to depend a lot on your top hot air and your preheating as well. It can be top IR like we're using. That's going to depend on that and how long you're there for. basically tinkering your profile, and that's going to require a lot of practice, or sorry, trial and error, or practicing and failing, or practicing and succeeding. But yeah, a lot of it is going to be that. Actually, there is also the idea of flux and reinstalling the socket. So another issue a lot of people have are cold joints. So cold joints can be affected by, so it can come around because of warpage, can come around because of uneven heating, not enough heating. Because the thing is, most of these replacement sockets, or 99% of them, come with lead-free solder. So the melting point will be that 217 degrees, 220 degrees Celsius. And so you do have to hit that. Some people, they have the misconception of, I'm going up to 190 degrees or 200 degrees, it's melted, it's in place, finished, I can, end the profile. So for example, memory module replacements or BGA chip replacements from China or other suppliers in the UK or in the US come with leaded solder. That is not the case for these sockets. They come with lead-free. Yeah, you have to keep that in mind, and this has to come up to at least 225, 230. We like to go up to the 230, 235 mark minimum, ensuring the whole area is actually melted and fully sat in place. Also doesn't require a second edition of Flux. So we're going to disassemble the board now and come back. Okay, as we've been taking that apart, we have noticed something just by the I/O shield. I think it's okay. We haven't actually looked at it under the microscope yet, so we'll do that just now. That looks like it's okay. Yeah, fine. There's a bit of a scratch here to these traces and that VO over there, but other than that, yeah, it'll be okay. These are good things to look out for, because if you finish your repair and it's not working, you're going to be very upset, and you're going to be even more upset if you did think in the beginning that was a socket replacement. You think you messed up your socket replacement, there's a cold joint, or it's half, soldered on, or there's a short somewhere, my goodness, what should I do? It could just be something simple like that. So keep your eye out and always double check everything else. Doubt yourself after you have a reason to. And yeah, so we're just going to continue with that assembly now. We just wanted to mention that it's very important that you remove the CMOS battery. If you do heat it up, since it is very sensitive, it can inflate and then end up blowing up. So do keep that in mind. Please remove it. And yeah, perfect. We're back, and as you can see, the board is fully disassembled. We removed things like the CMOS battery, any plastic tabs for the M.2 SSDs, as you can see. You can leave them there if you want them to melt and look like little ice cones. But anyways, the board is looking quite good. There were a few issues. We did see these traces being exposed, which we will cover up. Thankfully they're not damaged. Along with, they kind of forced the CPU cooler bracket into the board, damaging the PCB in a aesthetic way. None of the traces or anything are actually damaged. Before we actually get that onto the preheater and all these little tabs put onto it for our specific BGA station, I want to address that. Yes, you can sometimes, if you would like to use one of these plates, you obviously remove this black kind of sticker. You basically attach this plate, and without these two brackets, you just put the screws back in. So that plate kind of holds it flat, keeps the board uniform, especially in this area. You don't actually need it if your profile is good enough, or if you trust that the board is not so heavy, or it's got enough support around these areas. Our BGA station, the top heater actually has a added module which kind of covers these capacitors for us. It kind of comes down and has like an aluminium shield. I will bring one quickly to show you. So this is an example. So the top plate will kind of be up here. This comes down, covers the socket perfectly, and these caps are all happy. We've actually done it without any of these plates, and we have been able to remove the socket without inflating or exploding these caps. It's all done in the name of getting the perfect profile, or as good of a profile as possible. And yeah, so for those that don't have this, which will be a handful, you can use one of these. So an aluminium sheet, you just order yourself 0.8mm, 1mm, 0.6. Cut yourself some of this, bend it in half. That can just come like this, and just on top of obviously this one's a bit too big, you can just come on like that. So that one will fit there, and happy days. The top heat can go there. These capacitors are protected. You can sometimes get away with leaving the thermal pad for the PCH. We prefer not to. That's the thermal pad there. But to remove it, you know, save from degrading or bubbling and all the sort of headache. Takes 2 seconds and you can remove it quite safely most of the time. Sometimes it's thermal paste instead of thermal pad. And yeah, let's get right into it. We're going to get this onto the heat plate and meet you back there. This is now prepared for the BGA Rework machine. We're about to jump to that now. Just to mention, we've quickly cleaned the board of any thermal paste. The socket is okay because that's going, you know, that's going to get binned. The board itself, we don't want that thermal paste to get baked in from the heat. Anything else, these little bits will actually go into ultrasonic cleaner, get rid of all the thermal paste from them, and everything else is okay with the board, so let's jump right in. Okay, we've just taken you guys under the microscope to show you the flux residue. This is not too bad, so if I just grab a Q-tip quickly and some isopropyl alcohol, as you can see, it comes fairly easily. Yeah, so that part is quite good. The reason I'm showing you this is because it's actually a common mistake that a lot of people make where they overburn the flux. Either they're using a low quality flux, or if you are using a low quality flux, it's a good idea to run your soldering iron around the socket, clean it, and then run your soldering wick. Otherwise, when you're using a cheaper flux, you do run the risk of burning that flux onto the board. As you can see, we've got the socket perfectly clean. There were some cold joints that we had to address around this area here. We just do that by scratching it slightly and then adding some flux and some solder. That creates the clean joint again, ready for the socket to be soldered onto. Otherwise, that can get in the way and actually cause an issue or a, how do I say, a block between the two connections, and there won't actually be a proper solder joint that forms. So quite important that you do that. You can get away with it sometimes, but better not to risk it. Better to be safe than sorry. And so we suggest, yeah, just taking 2 minutes out of your time and getting that done. Right now, that looks perfect for a new socket. So we're going to grab our flux. We use something called Alpha OM338 PT. So we're going to grab that now. As you can see, this is our clean board with the flux application. If that will focus, you can then see the cleaned up area. We're going to now grab a new socket. It's an LG A1700. There we go. Now there is an alignment to these. When we take them off, we look for a little triangle on the bottom left. You see just there? It's a little triangle indentation. If you can't see it too clearly, we will take a photo and then annotate it, but that should be visible. So compared to the top right corner, you can see there is no triangle. Same thing here on the left, and the bottom right, just here. It's a little kind of right angled chip to that plastic. We've been doing this manual alignment for God knows how many chips, maybe over 600-700. And we haven't had an issue, so don't worry if you are looking for a machine that doesn't have this, you know, optical alignment feature. There we go. So done that in about 2 seconds. You can see it is perfect if I bring that close enough. There we go. So good at the bottom, good on the left, good on the top, and good on the right. What you're looking for is just a thin line. Let me see if we can get a flashlight quickly, or some sort of light, so you can see that right side a bit better. You can see it, okay, perfect. So yeah, you're just looking for a marking of the white line on each edge of the socket. It's a little bit more difficult or tricky with AM5 sockets, especially on the boards where they don't outline it properly for you. The outline is actually inside where the socket kind of sits, so you kind of have to feel for it or take a photo and kind of follow that. For us, we get a feel for it. And most of these holes are kind of got like a dip in there, so when you feel for it, you can feel the socket kind of nudge into place. So for us, this is perfect. It's going to go back onto the BGA Rework machine, and we'll meet you back there. Okay, so we're back on the preheater. We'll give that a few minutes to actually get up to temp, and then we'll meet you back at the soldering process. Okay, we're happy with that alignment now of our top heater. As you can see, we can take it all the way down, and we can bring it up, and the socket is in the same place, which is perfect. Now what we're going to do is wait for the board to hit temp until it's reached about 180, 190 degrees Celsius, and then we'll come in with the top heat. Okay, we're coming up to the end of the profile now. Great, so that's complete now, and as you can see, the socket looks pretty good in terms of its condition, if that will focus. Fantastic, but additionally, we need to check its alignment. So if we take a flashlight, you can see the bottom of the socket looks perfect. We can just about see the white line. Same thing with the right side, and then the top, as you can see, and then the left side. Fantastic. So the socket in place, I think we need to replace the battery on there. With the socket in place, we can also see the electrolytic caps look almost perfect, as good as new, I'd say. You look at that from the side. And finally, let's have a look at the warpage of the board from the sides. That looks perfect, almost non-existent. I'd say non-existent actually. Is that going to focus? Yeah, perfect. So straight. We don't reapply the flux at the end of the profile, and we do not nudge the sockets. That is what we do, what we don't do. And yeah, so anyways, we're going to get the ultrasonically cleaned brackets, assemble them here, get our LG A1700 socket tester, and show you the results. Alright, so that's just one more close-up look at the socket itself, from the sides and around it. And also keep in mind, you're looking for the inside as well. Why? Because when you're using the flux, if you're using a very cheap flux, or even a flux of good quality, if you either burn it or the activation doesn't reach, you get this kind of crusty old gunk in between, under the socket, which is just underneath these pins. So when you have a CPU placed in and you actually pull the hinge mechanism down, you hear a bit of a crunch. It's not the best sound, but that's not the main worry. The main worry is that over time, those connections, these little gold pins, actually get affected, or even those solder joints get affected by that gunk and that rubbish all underneath the socket. Unless, of course, you clean it with a very good ultrasonic cleaner, because again, with that kind of cheaper flux or flux that has been burnt, it's very difficult to get rid of. And yeah, so perfect. That's the front of the board, and that's the back. We did remove that ASUS sticker. And happy days. So let's just get this bracket on. Let's get our socket tester now. So as you can see, nice bright lights all across the board. Now keep in mind, if you do purchase this tester, it does not 100% guarantee that the socket is placed properly. It will kind of give you an idea that the connections are there are no shorts, but it does not mean that there are some weak connections or even a few like half open lines. It will not tell you that. So this is just a, let's say, a halfway or 50% confirmation or indication that you've done a good job, and then the rest will actually come when you've put the CPU in with some RAM sticks, which is what we're about to do now. So give us 2 minutes. So with the CPU in, I just want to show you the PCIe tester that we use. We tested this, but just to show it to you guys, that is perfect. If I were to show you half results, so for example, when the CPU is half plugged in, so that's with this halfway down, you will see that the results are skewed, okay? That also confirms for us a good connection to the CPU, to the PCIe slot. Perfect, so with everything set up, we've got 4 RAM sticks in there, DDR5, we've got an i3 12100, then the GPU is just a 1650 Super. So that's just to test the main functionality of the CPU connected to the RAM and the PCIe slot. Lovely, so let's give that a shot. So we've got the code running, and we will give that about a minute. And that should be a good sign. We should be booting if we look at the screen. Fantastic. So that is good news. If I just get our wireless keyboards. So if I bring you now to the test bench screen. Amazing. So here we are. I'm going to go into the simple view. We've got 4 RAM sticks all running at the right speed. Temperatures are all okay. and fantastic. I'm happy with that. That is the board now after the repair. With the board working, we'll invoice the customer the final fee and we'll have it sent back today. So we hope you learned something new. If there are any extra bits you'd like us to expand on, I'm happy to reply to any comments. You can message us on YouTube, on Discord, and we'd be happy to help. Anything else from this repair? Yeah, just keep in mind, try and practice on your own devices, and if you are buying a device to practice on, sell it in good faith. If you have tampered with it, don't, kind of hide it up, the repair and then try to sell it and make up your, most of your money. Try and go into this in the most, ethical way, and hopefully you also get your money back in the most ethical way. That's when you're selling your broken device and when you're getting repairs in, hopefully, in the next few years. So thank you very much. All of you take care and see you later. Bye-bye.